In this last part of working with complex numbers, we're going to talk about how we divide complex numbers. So, in order to divide complex numbers, you need to multiply the numerator and the denominator by the conjugate of the denominator. So essentially we are rationalizing, in a way, the denominator here, only we're using complex numbers instead of just radicals. So what would the conjugate of 1 minus 3i be? Well, that's right, it's going to be 1 plus 3i. So I'm going to multiply my numerator and the denominator, in this case, by 1 plus 3i. And what you'll see is the denominator will eventually work itself out, so it no longer has a complex number in it. It will just be a regular whole number or integer. Okay, so let's try it. What is the conjugate of 3 plus 7i? Well, that's going to be 3 minus 7i. And we're going to do that to both the numerator and the denominator. So when I'm multiplying these, remember I'm essentially FOILing. So in my numerator, I have 18 minus 42i. Lose spot of that little button. 42i. And then I'm adding 3i to that. And then I have a minus 7i squared. Okay. And then in my denominator, what I have is 9. And then I have a minus 21i. And a plus 21i. And a minus 49i squared. So to simplify, remember, over here with our negative 7, I squared is negative 1. So this becomes negative 7 times negative 1. Okay. And so this becomes a positive 7. And I'm going to put this positive 7 together with the positive 18, and that gives me positive 25. I have a minus 42i, but a positive 3i, so that gives me a minus 39i. Similarly, in my denominator, I have a minus 49 times the I squared, which is negative 1. So this becomes a plus 49. And when I add 49 and 9, I get 58. Okay. And then my minus 21i and plus 21i cancel. So this is as far as I can take this problem. I end up with 25 minus 39i all over 58. Unless, of course, my 25, my 39, and my 58 all had a number in common, a common factor. Like if they were all divisible by 2, I could factor that out and cancel. Okay, so what is the conjugate of this denominator? Well, remember that 4i is the same as 0 plus 4i. So my conjugate would be 0 minus 4i, or a minus 4i. Okay, so when I multiply the numerator, I get negative 36i plus 8i squared. And in my denominator, what I get is a 0 and then a minus 16i squared. Remember that anytime I see that I squared, it's the same as negative 1. So this becomes 8 times negative 1. And this becomes negative 16 times negative 1. So what I end up with is, I'm going to go ahead and write the real part first. This becomes negative 8 minus 36i. And then in my denominator, I get a positive 16. Now remember I said if I can factor out the same term out of all three of these, then I need to do that. So what I end up with is, I'm going to factor out a 4, and that becomes negative 2 minus 9i all over 4 times 4. So my 4's will cancel here and here. So what I'm left with is negative 2 minus 9i all over 4. Okay. The last thing we're going to talk about is how you can simplify powers of I. And As long as you can express in terms of I squared, you can replace any I squared with a -1. Okay? So I to the 5th, that's really I squared times I squared times I, right? So there's 1, 2, 3, 4, 5 there. Well, that's really -1 times -1 times I. Well, -1 times -1 turns +1. +1 times I is just I. So my final answer here, I to the 5th, actually just equals the same as I. Well, what about I to the 15th, right? Well, you could think of this and writing these all out, right? So I've got 2, 4, 6, 8, 10, 12, 14, and then I have my last one, 15. So all of these become -1s. So I've got 1, 2, 3, 4, 5, 6, 7 times my I. Well, let's think about what happens here. So -1 times -1, that turns positive. But when I multiply times -1 again, it turns negative. Another one makes it turn positive, negative, positive, negative. And so I have -1 times I, which is -I. Very good I there. Okay, and that's what I get. So notice that my first answer simplified down to just I, and my second one simplified down to -I. Well, I can also think of these problems as I squared raised to a power of something else. So this becomes I squared raised to the power of 20, right? Because when I raise a power to a power, I multiply. Well, this becomes then -1 to the power of 20. So imagine, if you will, if I have 20 -1s written out, what would I end up with? Well, remember, every 2 of them turns to a +1, and there are 10 sets of 2, so they all turn to a +1, so this is just 1. And similarly, I to the 26th, well, that I could write as I squared to the 13th, which is -1 to the 13th power. So think of if I had 13 of those -1s all strung out there, what would I end up with? I'd end up with -1. Interestingly enough, there's a pattern that goes on here. So I to the 1, I squared, I to the 3rd, I to the 4th. I want you to just look at this for a second. I to the 1st power is just I. And I squared, we know that that's -1. Well, I to the 3rd, we said that that's really just I squared times I, which is -1 times I, right? So -1 times I, which is -I. And I to the 4th is really I squared times I squared, which is -1 times -1, which is +1. So look at these answers for just a second. Okay? These are important. Now let's think about what I to the 5th is. Well, that's really I to the 4th times I. And then let's look back at what we have here. Well, I to the 4th is 1. And I to the 1, or just I, is I. So this becomes 1 times I, which is I. I to the 6th is the same as I to the 4th times I squared, which is 1 times I squared, which is -1, so that becomes -1. I'm hoping you're going to see a pattern going on here pretty quick. This becomes I to the 4th times I to the 3rd, which becomes 1 times a negative I, which is just negative I. And then I to the 8th is I to the 4th times I to the 4th, which is 1 times 1, which is again 1. Notice it goes I, negative 1, negative I, positive 1, I, negative 1, negative I, positive 1. This pattern is actually going to continue as you continue to go up to higher and higher powers of I. And I encourage you to test it out and see what happens as you get to even bigger numbers, even bigger powers of I. Essentially, you can figure out I to a really large power without actually working it out on your calculator if you take the exponent. So let me give you an example. Let's say we're going to do I to the 231 power. Okay, that's really big. So what you do is you take 231 and you divide by 4. Okay, because I to the 4th power is equal to 1. So every time, for every 4 of those you have, you get 1. So 231 divided by 4 gives me 57 and remainder of 3. Okay, so what this means is that I have 57 sets of I to the 4th. So which every single one of those turns out to be 1. So I have 57 sets of I to the 4th, which are all 1. And then I have an I to the 3rd. Well, what is I to the 3rd? So I have all these values of 1, and then I have an I to the 3rd. Well, I to the 3rd is negative I. So I to the 231 power is the same as an I to the 3rd, which is negative I. I encourage you to think about that a little bit more. Try a couple on your own, see what happens, because this is going to be something you're going to need to pay attention to later on. Okay? For now, that's the end of our work with complex numbers. Good luck on this work. I'll see you in the next video.